Okay, how do we determine the period of the function? Right. So my period is going to be 2 pi over 4. So that's pi over 2. So that means it's going to take pi over 2 units to complete one full cycle. And the amplitude is 2. Okay, so how do we graph this, right? We put our point, our x-intercept at the beginning and at the end, and then at halfway. And then we plot a point between those x-intercepts, representing the amplitude, which is 2. So 2 and then negative 2. So this goes like this. All right, so every pi over 2, I have the same thing going on. All right. And we can continue down the graph like that. Okay? Good with that? All right. Next one. Let's see. This is going to have, what's the period of this one? 2. Yeah, it's 2 pi over 1/2, which is 4 pi. Right? So it's going to complete a full cycle in 4 pi units. Halfway, we have another x-intercept. Okay, so then in between those x-intercepts, I have an amplitude of 4. So we go 4, and then we go negative 4.
Please disregard that bell, thank you.
Okay. And there we go. Okay? Questions on that? All right, this one's easier, right? What's the period? 2 pi. So 0 and 2 pi, halfway, we have another x-intercept. Halfway in between, we have our amplitude, which is 1/2. So this one doesn't go up as high. And we're done. Oh. Next page is in degrees. So here we've got a period of 2 pi over 2, which is pi. So now we want to convert that to degrees. So 180 degrees is my period. Okay, so halfway between that, so each one of these marks looks like it's representing 30. Halfway between that would be 90. And then I've got an amplitude of 1/2 again. So now I've got to kind of estimate. There's my 45 degrees. And there we go there. So it looks like that. Are we good? Okay. All right, so here we have 2 pi over 2, which is 180, or pi, which is 180. So same thing again, 180 and 0, and then halfway is 90. And then halfway, I'm just going to make little marks there for the halfway. We've got an amplitude of 4. And then we've got to go down to negative 4. And there we go. No problemas? Okay, so this one, we have 2 pi over 1/3, which gives us 6 pi. And 6 pi is, let's see, 360 times 3, 1080. Okay. So halfway would be at 540. So let's see, each one of these is 180, so 540 is right here. Okay. And let's see, so halfway, so sometimes I just kind of look at the tick mark. So halfway is going to be right there. And there's halfway. And this has an amplitude of 2. And there we go. Okay? You feel comfortable with that? Okay. That's good. Put your books away. We have a homework quiz. Pencil only, no calculator. Okay, so today we are going to graph a cosine function. Okay, so cosine, what do you think the period of cosine is? What's the period of sine? 2 pi, thank you. The period of a sine curve is 2 pi. So what's the period of a cosine curve? 2 pi, right? 2 pi. So it's one full cycle of cosine is 2 pi. Okay, so what is the cosine of 0? 1. The cosine of 0 is 1. The sine of 0 is 0. What's the cosine of 2 pi? Okay. Okay. How about in between? What's the cosine of pi? -1. Yes. Gotta know the unit circle. Oh, I'm sorry. I'm sorry. I didn't hear you. I'm sorry. Okay. All right. We gotta know our unit circle. Okay. The cosine of 0 is 1. The cosine of 2 pi is 1. The cosine of pi is -1. Okay, so when we were graphing the sine function, okay, I'm just going to kind of sketch the sine function in here. Okay, when we were graphing the sine function, we plotted at 0, we plotted at 2 pi, and then we plotted in the middle, right? And then what did we do? We went in the middle of those, right? So let's do that with cosine. What's the cosine of pi over 2? 0. 0. Cosine of pi over 2. Right, here's our unit circle. Pi over 2 is right here. Okay. And the cosine of 3 pi over 2? All right, that's down here. Okay. So our cosine function looks like this. It's not flipped, it's actually shifted. Okay, look what happens. What's the cosine of negative pi over 2? So if I went down this way, what's the cosine of negative pi over 2? 0. What's the cosine of negative pi? -1. Okay, so look what's going on with this curve. Okay, it's the same curve as a sine function, but it is shifted over pi over 2 units. Oops, didn't mean to go that far. Let me do that again, right? Right, there's your, it looks just like the sine curve, except the whole thing is shifted over pi over 2 units.
So would be tangent shifted over too?
No, tangent's very different. Very, very different, actually. Okay. Excuse me. So remember yesterday we were talking about the, actually, let me see if I can pull up the video. We were watching the videos with the Ferris wheel, right? Let's see here. Okay. So we learned about sine waves. Okay, remember the motion around the wheel, if we look at it vertically, okay, so remember we said, let's pretend that you're starting here. Well, that's the initial position of your vector, right? That's the initial position. And then as we go around the Ferris wheel, we're changing position, okay? The sign on your unit circle, what does the sign represent? The X or the Y? Y. And Y is the up and down, okay? So this scenario in this video, we're watching the Ferris wheel, watching the person go around the Ferris wheel, but when we look at it this way, all we're seeing is the vertical. Remember, we said the guy's kind of standing to the one side. The guy's actually standing over here and watching. He's standing right here and he's watching the Ferris wheel. So all he sees is the vertical position of the person on the Ferris wheel. And that's the sine value. Okay. Notice where they are vertically. Notice where they are as far as the height goes. And that's what they're seeing. That's the sine value. Okay, before I go on, do you have any questions with that part of it? Okay. Okay, so we're familiar with this, right? Here's our rest position here. Excuse me. Okay, let me move on because I want to get to where he shows you the cosine. Let's see. Oh, I'm not talking about it? No, no, I don't care. Stop, 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 stop. Oh, I'm sorry. It's the other video. So sorry.
I think it's the little one.
Look at the guy with the cool accent.
Oh, the coal.
Cole. Cole's going to go to Cambridge and he's going to come back sounding like this guy. Okay. Okay. So here we have the Ferris wheel. As we move around the Ferris wheel, this yellow dot is representing the vertical position. Okay. And he's going to start plotting the sine graph. We saw this yesterday. Yeah. Okay, before I let him go further, right? So this curve right here, this one with the little balls going along, this is tracking the horizontal position. So as that blue cart is moving around the Ferris wheel, right? horizontally. First it's going this way, right? And then when it gets down here, it starts going the other way. So that's why we have this sine curve going up like that. But in reality, it's not a sine curve, it's a cosine curve. Okay, so I don't want to overcomplicate it. Let me just go back to where he was showing the diagram, showing the motion here. Okay. Okay. So now we see where the cosine comes from. When we look at the graph of a cosine function, it can be easily distinguished from the sine function, even though I just said they're basically the same shape except cosine is shifted. The way we recognize that it's cosine is by the y-intercept. A cosine function is going to cross the y-axis at 1, or basically at whatever its amplitude is, whereas the sine curve is going to cross the y-axis at the origin. Okay, so that's how we tell the difference. We're going to graph it the same way. So let's say that we have y equals 2 cosine, let's just do 2x, okay? So what's the amplitude? 2, okay? Excuse me. What's the period? Pi, right, it's 2 pi over 2. So the period is pi. So at 0, right, we're crossing the y-axis. So the amplitude is 2. So we're going to put our point here at 2. At pi, I also put my point at 2. Halfway in between, I'm going to go the other direction, and we're going to go down to -2. Okay. Halfway between those points, it crosses the x-axis. So remember, this is part of the sine curve, so we've got to have that curve to it. Okay, that same type of shape. Right. And there's my cosine curve. Okay, cosine curve, we're going to start and end up. A sine curve, we start and end at the rest position. Okay. Cosine curve, we start and end up. Sine curve, we start and end at the rest position. Okay. So let's look at y equals 3 cosine 1/2 x. 3 cosine 1/2 x. See if you can do that one yourself. And you can just graph one period of it. No. I gave you blank paper yesterday. You want some more blank paper? You got one? Oops, I want to do that.
How we do?
Okay, so what's our period? 4 pi, yeah, it's 2 pi divided by 1/2, which is 4 pi. Oops. Okay, so I'm going to put a 4 pi down here. So let's see, halfway in between, 1, 2, 3, 4. Okay. There's a 2 pi. Okay. Okay, so then halfway in between that, we've got pi and 3 pi. Okay, what's the amplitude? 3. All right, so we're going to start and end at the highest point. And where's the lowest point? Which is at the 2 pi. Okay, and then halfway between those points, we cross the x-axis. And there we go. Okay, that's our cosine curve. Okay, I have a worksheet for you to practice these. When we do that, then we're going to start looking at some phase shifts. Okay, so I'll give you just a few minutes to work on this worksheet. Okay, so I saw some of you kind of turning and asking each other questions, which is fine, it's good. But I'm just curious, what were the questions? What type of problems were you having? Are they all supposed to look like what? They should look like that, yeah. Can't find my pen. Where'd my pen go? Okay, so let's look at the first one. So we have y equals 3 cosine 3 theta. Okay, so we know the amplitude, right? The amplitude is 3. So we need to figure out the period. So that's going to be 2 pi divided by b. So 2 pi divided by 3. Ew, 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 right? So, but we're graphing this in degrees. So what is 2 pi over 3 degrees? 60 degrees? That's pi over 3. 120. 120 degrees, okay? So it's 120 degrees. So what I do, right, at the end here, I'm going to put, here's my 120, okay? So at 0, I'm going to go all the way up to 3. At 120, I go up to 3. Guess I should make that, take that off there, okay? And then halfway in between, which would be 60, right? So let me see here. That's going to be right here. We go down to -3, okay? So now halfway in between that would be 30 degrees. So let's see, that's going to be right here. It's going to be crossing the x-axis. And then here at 90, it crosses the x-axis. So we're looking at a cosine curve that looks like this. It is important that you get the shape correct, right? If you make it too angular, it's going to look like an absolute value function, right? So it is important to get that shape correct. Okay? Questions on that one? Okay. I think the hardest part is actually putting it on the graph, like figuring out the period and stuff. That's not hard. Okay, so let's say we have y equals 2 cosine theta over 4. Well, that's basically 2 cosine 1/4 theta. So we know where our amplitude is 2. Okay. Our period, that will be 2 pi over 1/4 or 8 pi. So that's going to be 360 times 4. So that's 720, 1440. No big deal. Put that last point as 1440. Okay. Okay. So that means we're going to be up to 2 at that spot. Halfway there is going to be 720 degrees. And that'll be down at -2. Halfway, get 360. And halfway, I think that's 1080. So the curve looks the same. It's just that our x-axis looks different. Okay. Okay. Those are the ones in degrees. The radians are harder to work with. Okay. Okay. Well, that's good. I'm glad. If you didn't have any trouble with it, that's good.
I didn't even like put mine in like degrees. I have all of them.
Okay. Well, the top two said specifically to do it in degrees, though, right?
Yeah, I saw that.
Okay, we get y equals 3 cosine 4 theta. Okay, so it has a amplitude of 3. So we've got the period is 2 pi divided by 4, or pi over 2. Okay, so let's just change these. So my period is pi over 2. Okay, we put a point up there at 3. Halfway, so pi over 2 times 1/2, that's going to be pi over 4. So this is pi over 4. And we're going to go down to -3 down here. Okay. And then we have to go halfway again. So pi over 4 times 1/2 is pi over 8. So right there at pi over 8. You do have to mark these on your x-axis. Now, halfway is pi over 8. So what's this value here? Okay, well, let's think it through a minute. Pi over 8 means that this is 2 pi over 8, right? Pi over 4 is 2 pi over 8. So this has to be 3 pi over 8. Get a common denominator, and then you can figure that out. Okay, and that's going to be crossing the x-axis at that point. So these markings on the x-axis have to be accurate. Since we're drawing our own graph with our own scale, they all look the same. But of course, if you were using the same graph, like from 0 to 2 pi, this one's going to look skinnier, right? Okay. Let's look at number 4. All right, so I have y equals 3 cosine theta over 3. So our period is 2 pi over 1/3, or 6 pi. And what was that? Is this, this is in radians, right? Okay. 6 pi. So we'll just make this 6. Okay. And make this nice and easy here. Okay, halfway will be 3 pi. So that means this is going to be 1.5 pi, or 3 pi over 2. And this one will be what? Okay, let's get a common denominator, right? That's 3 pi over 2. So this is going to be 6 pi over 2. So what will this one be? 9 pi over 2. See how once you get that common denominator, it's easier to figure that out. Okay, and then our curve is going to go up to 3. Okay. -3. Oh, Anthony, that sounded awful.
Did it relieve you of stress? They did. I felt very rejuvenated. You know what I'm saying?
Wow. Okay. I'm not gonna spend a lot of time on number 5. We've got 4 cosine. Oh, please stop doing it, guys. Come on.
Maybe my back feel better.
Well, do it later. Okay, so our period is pi, 2 pi over 2. So this is pi over 2. This is pi over 4. This is 3 pi over 4. We're going up to 4. And we're going down to -4. And there's our curve. Okay. Questions? Okay, pretty straightforward. Okay, so what I want to do now is I want to do our phase shifts. Okay, so let me just see if I can get some blank paper here. No. I think the radians are harder, aren't they? Because you've got to work with fractions. There we go.
That's good practice. That's good practice.
You don't have to do that one now. Thank you. Okay. No. I think I just crashed the system. Oh, come on. I don't have time for this. Standard form of our equation again. We're going to work with the sine curve just to learn this part, just because sine is easier to work with, right? Y equals A sine BX minus C plus D. Okay, so we've worked with the A, the amplitude, and we've worked with the B. Okay, so now we're going to look at the D, right? The D is going to shift it up or down. So let's say that I have Y equals, we'll just leave it as sine X plus 2. Okay. Y equals sine X plus 2. Okay, so what we're going to do, just like we did when we were learning about graph transformations before, right? We're going to sketch the base function in first. So we're going to sketch our sine curve in there just using a dotted line. Okay, so there's my sine curve. Now, if I add 2 to that, what does it do to my graph? It shifts it up, right? It shifts the entire thing up. So every single point is going to shift up 2 points. So basically, this becomes my new rest position right here. The line y equals 2 becomes my new rest position. So every one of my points moves up 2 units. So there's my curve up there. Okay. So it just moves every point up. So once you get your base function in there, just shift it all up 2 points, okay? So it's important to recognize just by looking at the equation, I don't even have to graph it. I know that the rest position is at y equals 2. That's the rest position of this function. So remember I talked about the rope yesterday, right? If we're swinging the rope up and down and all of a sudden we just pull it tight, that's our rest position, okay? Okay, but then what happens if we have something like y equals sine x plus pi over 4 plus 1? Okay, so let's look at that. Okay, I'm going to leave my base function there for you. Okay, so this one, what's going to happen with, what's that pi over 4 going to do?
Shift it left.
It's going to shift it left pi over 4 units. Yeah. So take every single one of our points, move it pi over 4 to the left. It's the same thing we did with our graph transformations. Okay. So this green curve, right? We're not finished, right? The green one is sine y equals sine x plus pi over 4. That's the green one. Okay, my final curve, now I need to shift it up 1. So I'm going to take every point and I'll move it up 1 from the green line. Okay. Now there are a bunch of different ways that this is taught, and there are lots of complicated ways of doing this. We're just keeping it nice and simple. Okay. I just want you to understand the shifts that are going on. Okay. Okay, let's make it a little bit harder. Let's do y equals 2 sine x over 2 minus pi over 4 plus, no, let's do minus 1. Okay. Okay, so when we look at that, in general, what are we expecting to see? What's the 2 in front doing?
Change period.
Yeah, it's stretching it, changing the amplitude, right? It's going to make it taller. Okay. What's the pi over 4 doing? Shift it to the right. It's always the opposite inside the parentheses. Shifting it to the right. What's the minus 1 doing? Shifting it down. So this is a curve that it's taller, it's shifted to the right and down. But then I've got this x over 2, which affects what? The period. Right. Okay, so let's figure out our period. Okay. So the period is 2 pi over 1/2, which gives me 4 pi. Okay. So my period is 4 pi. So I have to change these numbers here. 4 pi. So this is 2 pi. Right. Let's see. Pi, 3 pi. Okay, there's my period. Okay, so I'm going to sketch my basic function in here first. It's got an amplitude of 2. So here's y equals 2 sine x. Okay, y equals 2 sine x. Okay. I'm sorry. that's not correct. This is y equals 2 sine x over 2. Okay, everybody good with that? What do you want to do next? Okay, move it to the right, pi over 4. So let's see, this is pi, that means this is pi over 2, so I'm going to go basically half a square over, okay? So we're going to move over half a square to the right. Okay. Okay, so there's my y equals 2 sine x over 2 minus pi over 4. Okay? And now we got to move the whole thing down 1, right? So move it down 1. Okay. And there you go. Y equals 2 sine x over 2 minus pi over 4 minus 1. Now, how could I figure out where it's crossing that y-axis? Which basically would represent its initial position. No. So when it crosses the y-axis, what is the x value? 0. If it's crossing the y-axis, x is 0. So y equals 2 sine of 0 minus pi over 4 minus 1. So 2 sine of negative pi over 4 minus 1. Okay, so let's see. Negative pi over 4 would bring me right here. The sine is negative root 2 over 2, which is approximately negative 0.71. So we'd be looking at 2 times negative 0.71 minus 1, so negative 1.4 minus 1, so approximately negative 2.4. So it's going to cross the y-axis right about there. That's how we would figure out where it actually crosses the y-axis. Okay? Okay. Questions?
So it's always opposite in the parentheses.
Yes. Inside the parentheses is always opposite. Let me see here. Okay. I think we're going to stop there. And I'm not going to give you a worksheet. We're going to stop there. Okay?
So 3 classes.
Yeah.